Part A. The problem gives us the mass that is 30 kilograms, and part A gives us the force that is 30 and the angle that is 41, and asks us for acceleration. In this part, we have to multiply the cosine of the angle times the force and divide the result by the mass to get the acceleration is 0.75 meters per second squared. Part B. Part B asks us for normal force. We first have to calculate the weight that is mass times 9.8 and give us 294 as result. Then we have to make an addition of the weight plus the sin of the angle times the force. This calculation will have the normal force is equal to 313 newtons.
Okay, so we are gonna continue with problem 2, exercise 2. And it says, unless otherwise stated, all objects are located near the Earth's surface, where gravity equals 9.80 meters per second squared. A block of mass of 22 kilograms slides down a frictionless surface inclined at 33 degrees. Part A. To ensure that the block does not accelerate, what is the magnitude of the smallest force that you must exert on it? Express your answer using two significant figures. It says that we need to express or find force. That is, and the formula is mass per gravity by the sine of the angle. And well, the force is equal to 120 newtons. And well, now we're going to continue with part B. It says, what is its direction? And here it is, up the incline. Well, that's all. Thanks.
Hello, my name is Roberto Landa Flores from group 308. And in this problem, first, I have to indicate the normal force and the weight, the true force, and the tension force. And based on some calculations, I was able to point the hourglass you can see in the image. Then, to find the tension force, I multiplied the weight 11,564 by sine of 25 over cosine of 31. And how result, I obtained 5,700. 5,700. And in the part C, I to find tension force to be I multiply the weight by cosine of 25, and the result is 10,480.54. Then I rest the result by 5,700.52 multiply by sine of 31, and the result is 7,544.04. In this problem, I was able to deduce that there are two forces in this problem. And the acceleration I obtain by multiply the gravity for 36 and then 9.8 sine of 36 is equal.
Hi, I'm Ricardo, and I'm going to explain the problems 5 to 6 of Mastering Physics. First, we have problem number 5, which says, in moving a 39 kilogram from one side of a classroom to the other, a professor finds that a horizontal force of 275 newtons is necessary to set the desk in motion, and a force of 205 newtons is necessary to keep it in motion for a constant speed. So there is no acceleration in this problem. The first question says, what is the coefficient of static friction between the desk and the floor? I used the formula to find normal force, which normal force is equal to W, to weight. So it's 39 times 9.8, and then it gives me 230.83, and then the formula of the coefficient of static friction is that that value divided by the first force, which is 275 newtons, and it gave me 0.72. Then the part B, it says, what is the coefficient of kinetic friction between the desk and the floor? Which is the same formula, and it gave me 0.53. Now, to the next problem, it says, if the coefficient of kinetic friction between tires and dry pavement is 0.71, what is the shortest distance in which you can stop an automobile by locking the brakes when traveling at 25.5 meters per second? To find out, I use the final velocity square equals initial velocity formula, and first the distance gave me 45.7 meters. Then on part B, it asked me, on wet pavement the coefficient of kinetic friction may be only 0.25. How fast should you drive on wet pavement in order to be able to stop on the same distance as in part A? Here I use the same distance and multiplied it just 2 times 2.45, which is the result of multiplying the kinetic friction times the gravity, and it gave me 15.9, and that will be the velocity you will need to stop at the same distance.
7 of Mastering Physics. In part A we have this data. For the formulas we need to use the weight that equals mass times gravity, because weight is equal to the normal force that we need to have to get the horizontal force. Then we substitute 11.7k times negative 9.8 equals to 140.66. This is the new 0.23 equal times 140.66 is equal to the 26.4 newtons for the horizontal force. In part B, we only need the acceleration, that is get by mu times gravity, and it is 0.23 times negative 9.8 equals to negative 2.25. These are the final answer for part A and the final answer from part B.
This is the problem A for Mastering Physics. First part, we have the part A, that is graphic the direction of the vectors. We have here the neutral is go straight up, the weight is straight down, friction horizontally, and this is the force. We have this, the data that give us the problem, weight, force, the angle, and the mu. For part B, we have the neutral. The neutral is with F and Y plus the weight. F and Y is the force times the sin of the angle plus the weight, that is 170 newtons. From the part C, we need to get the friction force, that is equal to the F in X. F in X is the F with the cosine of the angle, that is this, and is equals to 77.1. In the part D, we have the maximum friction that we can apply, and is the neutral times the mu, that is equal to 170, the answer for part B, times the 0.72, the mu, equals to 77.1. And for part A, we have the neutral with other value, that is the weight minus the F and Y. Here we inverted this, and is 125 minus 89 sine of 30, that is equals to 12.2 newtons.
Okay, hi, I am Mario Moreno, and today I'm going to explain problems 9 and 10 from the stage 4. Now the first problem of these two, that is the problem 9, gives us some data, that is the mass and the tension. How the tension that the rope will break if the tension exceeds the tension that gives us right there. And part A asks us for tension if the angle is 10 degrees. We are going to first write the data, and we are going to find the weight that is really important for these problems. That is and we find the weight multiplying the mass, that is 90 times 9.8. We are going to use the formula that is right here. We are going to solve that what we have, that is the sine of 10 and the W, and then we are going to multiply the 2 times the 1.73, that is the sine of 10, and we will get with this that we are going to divide, and we are going to get 2,549. That is rounded, is what we have right here. And now part B asks us for the smallest value that the smallest value the angle can have if the rope is not to break. We are going to use the data that they gave us here, the tension if we exceed that, and we're going to use the same formula that right here, but now we are going to solve for the angle. We are going to divide W over 2 times the tension that we have right there, and this division will give us as our results 0.0126, and as we are searching for angles, we have to use inverse sine of what we have here, and it will give us that the smallest value that the angle can have is 0.72. Now we're going to go with a problem number 10, that in first part give us the mass, and the first thing that it asks is for us to complete this free body diagram. It's simple. The weight always goes completely down. The tension to the left goes to the left rope, and the tension to the right goes to the right rope. Now part B asks us to find the tension in the left cable, and part C asks us to find the tension in the right cable. So we have the following data. It's also important, again, to find the weight, that is the mass, times 9.8, and in this case the weight is 636. The key formulas, or the key equations that we're going to use to solve this problem are these. That is T1 of y plus T2 of y equals to the weight, and T1 of x is equal to T2 of x. We are going to find all the forces that I mentioned in here with these formulas. That is the T1y. When it's y times the sine of the angle, and when it's x, the cosine of the angle, and we are going to get the following results that are right here. Now with these results, we can substitute them in the formulas that we have right here. And we are going to find first the first formula using the y forces. We're going to get this equation, and using the x forces, we're going to get this. That if we continue solving it, we will have this division that is right here, 0.819 over 0.669, and we will find as a result of this that T1 is equal to 1.22 times T2. Now with this, we can substitute in the other formula, the one that is right here, the first one, with the 1.22. We are going to multiply, first of all, these two values. We're going to get 0.9 times T2 plus 0.574 times T2, and this is equal to the weight. Now we're going to make an addition of these two numbers, and we will get this number right here, 1.484. It's equal to the weight, and now we simply do the division of 637 over 1.484, and we will get 429.24 as a result. And this is the tension of the left cable. And now we're going to use this equation that we got right here to find the T1, that it will be the right tension, because we already know what T2 is. So we're going to simply do this multiplication of the 1.22 times T2, that is 429, and we will have as a result 523.67, and this is the result of the tension of the right cable. And this was problem 9 and 10 to conclude Master in Physics of Stage 4.